Alright. Hello everyone, my name is Daniel. I am a final year medical student. I'm done with my step 1 and step 2 CK, and in this video we're going to discuss about cellular adaptation. This is a series of basics pathology, and in this series we're going to cover a major chunk of basics pathology uh, so that you remember the core principles of pathology in every walk of your medicine. Alright. So let's talk about the cellular adaptation. Now, what is cellular adaptation? Cellular adaptation, let me give you an example. For suppose there is a cell and you are providing any stress, any sort of physiological or any sort of pathological stress to the cell, and in response to that stress, cell make changes. All right, the cell make changes, and those changes are reversible changes. Means if you withdraw the stress, those changes will reverse. All right, so if you are providing a stress and cell makes reversible changes, all right, these changes are to ensure the survival of the cell, so these changes are called cellular adaptation. Alright, now if these changes are not, if the cell is not making these changes, so cell won't be able to survive, and this would lead to cellular injury. So it's a very basic concept and a simple concept. Like, for suppose if you're providing a stress to someone and someone is not able to get over that stress, and someone is not able to handle that stress, so ultimately that will lead to this injury. All right, for suppose there is a cell and you are providing injury to the cell, and that cell is not able to take over that stress, and the cell is not able to cope up with the stress. Now the cell is not making the changes. Of course, the cell will not be able to survive, and this would lead to the cellular injury. Now, if the injury is severe or prolonged, or if it is for a long time, right, and this ultimately the cell will not be able to reverse the changes, or the cell will not be able to the changes that occur in response to the injury, and this would lead to the cell death. Alright, so that's a sum up, and that's a simple story of cellular adaptation. You are providing a stress, it is leading to the functional changes and reversible changes, and this is called as cellular adaptation. Alright, okay. So, why do cell adapt? So, the reason why the cell adapt is written over here, and it is simply if you're providing a stress, right, and in response to the stress, cell have to function more. So, for suppose if you talk about the muscles of the heart, and if you are providing a lot of blood to the heart or a lot of pressure to the heart, and then you have to function more, and the cells will divide. So the cells of the muscle will divide. So this is the response of the increased workload, right? So the cells the cellular adaptation occur due to increased workload, right? If you're providing a lot of work to the cell, if you're providing a lot of things to the cell, if you're providing a lot of functions, or if you're providing a lot of you can say works in simple words, then it will lead to the cellular adaptation in the form of hypertrophy or hyperplasia. Now, if there is decrease in nutrient, if the nutrients are decreased, then it also leads to the increase. It also leads to cellular adaptation. The cell will respond in a similar way. If there is irritation and if there is hormonal stimulation, this all leads to the increase. This all leads to cellular adaptation. I'm not saying increase or decrease. It depends on the condition, and I'll talk about this in the next few minutes. Right? So it's a very good line written over here that adaptation helps the cell reach a new steady state. So when the cell adapt in response to the adaptation, the cell reach a type of a state in which the cell can survive, the cell can function, and this is a steady and a stable state, right? So adaptation leads to the stable and functional viable state of the cell, right? Okay. So, cellular adaptation is an active and regulated process. It is an active process. There is gene regulation over here. It is not something that is pathological. Cellular adaptation is a physiological process and regulated process. It is regulated by some genes, by some channels, and by some sort of transportation, right? So it's a very regulated process. It is not random. Of course, the cellular adaptation is not a random process. It is occurring in response to some stress, and it's a programmed survival. These last two lines are a golden principle in order to retain the concept and understand the concept of cellular adaptation. Okay, so the classification of the cellular adaptation would be the hypertrophy, in which the cell size is increased, the hyperplasia, in which the number of cells is increased, atrophy, in which there is decrease in cell size or cell number, and the metaplasia, in which there is a replacement of one type of cell with the another type of cell. All right, and again, these all are reversible injuries. These all are reversible changes. Like if you remove the stress, if you remove the stimulus, then these injuries, you can say these changes will also be these will be reversed. All right, and you will again reach to the baseline state again once these stress are removed. So now, I want to, of course, this is a different topic. Cellular injury is a different topic, but I literally want to make you understand that there is a fine line between the adaptation and the injury. If you cannot adapt, you're gonna be injured. Keep this in the mind, in the back of your mind, throughout your life. If you are becoming a doctor, keep in mind, if you're not able to adapt, you're gonna injure. All right. So if adaptation is the cell is functioning within the limits, cell is able to perform the function within the stress, right? This is the adaptation. For suppose you are in a very hectic environment, you are in a very stressful environment, like you are working as a resident in the USA, and you got to deal a lot of patients, a lot of things you're gonna do, and if you are able to take cope up with the stress, then you're gonna be a very good resident. All right. So this is what adaptation is. You are able to function, you're able to perform under a stressful environment. But if you're not able to do that, if you're not coping up with the stress, then ultimately it will lead to the depression. All right, and that depression is a form of injury. It's a form of injury to your mental state. All right, so that is what injury is. If you cannot perform in the stressful environment, if you cannot respond to the stress in a very physiological and in a very homeostatic way, then it would lead to the cellular injury. All right. Now, adaptation is a pre-injury phase. This is a very good definition. Adaptation is something that is gonna happen between the injury. The reason why I'm saying that, because if you are adapting, and ultimately, now understand this concept very well, please. First, suppose if I'm providing a stressful stimulus to the cell, now cell reaches to a state in which the cell adapt to that situation very well. Okay, that's perfect. The cell is adapted to the injury. Cell is functioning well. Now, if you provide more and more and more stress, ultimately it will lead to the state in which cell cannot respond to the stimulus. Cell cannot respond to the stress, and that would lead to the injury. All right, so you can say, in other terms, you can also understand this in a way that adaptation is just a pre-injury phase. After adapting to your injury, for suppose you are in a very hectic environment, you are working as a resident in the USA, and you think, for suppose, that you are handling a lot of stress at the same time, you are handling the very stressful job, and at the same time, God forbid, something bad happens to your family. Now, at that time, you are not able to cope up with the stressful environment of the work, and you are not able to cope up with the stress, the family stress at the same time, and that might lead to the collapse. You might collapse. There is a chance you might collapse. There is a chance you might give up, right? And if you give up, then this is called as the injury. All right, keep this thing at the back of your mind. It will be very helpful that adaptation is, and there is a very fine line between adaptation and injury. So try to be out of this stressful environment as soon as possible. This is for the cell, not for you. Okay, persistent stress can convert. Yeah, this is what I said, and this is so display just something that I will explain into some in the next video, and I don't want to be and I don't want this to be part of cellular adaptation due to some reasons that I will explain in the next video. All right. Okay, now our first core classification of the cellular adaptation is the hypertrophy. All right, so let's talk about the hypertrophy. So hypertrophy is just you are increasing the number of cells. Sorry, you are just increasing the size of the cell. You're not increasing the number. Trophus means the size, always, right? And again, it's a reversible process and adaptive response to the stress. So it basically occurs in those cells which are not able to divide. All right, that's why they are being increased. They are increasing in size because they cannot divide. And the classic examples for such type of tissues or cells is the cardiac muscles or cardiac tissues and the skeletal muscle tissues. And when they are exposed to the workload, when they're exposed to the increase the stress rather than dividing, they just increase in size. All right, the mechanism, of course, I've explained the mechanism here, that if it just involves the mechanical stress, right, or growth factor mediated signaling. What actually happens that you give the stress, and this leads to the increased number of growth factor released from the cells and from the genes and from different areas of the cell, which I'm not going into the detail of that. And those growth factors ultimately leads to the increased gene expressions, and this gene expression leads to increased protein synthesis. You know that gene always leads to the protein synthesis, and increased protein synthesis leads to increased organelle production, and that's how the size of cell increase. So a short summary of this would be mechanical stress. This mechanical stress leads to the increased number of growth factor signaling pathway, and this growth factor signaling pathway ultimately produce a lot of growth factors. These growth factors induces the gene transcription and gene expression, and gene expression increases the protein synthesis and the organelle synthesis, and ultimately the size of a cell is increased. So this can be physiological and pathological. Of course, if you are increasing the, of course, if you're exercising, then exercising is not something pathological. It's a physiological way. Physiological way of a body to respond in response to the in response to the exercise. Because if you exercise, your muscle gonna increase in the size, and that's what called as that's what called a physiological response. All right, and it can be pathological in case of chronic hypertension. When there is chronic hypertension, there is a lot of increased afterload to the heart, and there is increased afterload to the heart, then there is increased stress to the heart muscles, and this will lead to the left ventricular hypertrophy. So again, it is initially compensatory, but if you are providing the persistent stress, if you're providing a lot of stress back to back, then again the cell, there's a fine line between the adaptation and the injury. And again, if you're providing a lot of stress, it would lead to the increase number increase in the a lot of so again, let me explain that again. If you are providing persistent stress to the cell, if you are providing persistent increased workload, then this would lead to the functional impairment. How? Let's talk about the heart muscle. You are providing a lot of afterload, you're providing a lot of pressure, so right, you're providing a lot of workload, so it will lead to the increased size of a cell. Ultimately, the size of cell would increase to at that point that the blood supply to this increased sized cell is not sufficient, and this will lead to ischemia. Right, the more you are growing, the more you need blood vessel, the more the blood you need. The more you are growing, the more the blood you need. This is for the cell. If the cell is growing, it needs blood. But again, you are increasing the size of cell, not the number of blood vessel. So again, if you're providing a lot of stress, the size of cell will lead to a point that it needs a more blood, and again you are increasing the size of cell, not the number of blood vessel, and this will lead to the ischemia and eventually cell injury. And if you're talking about heart, then it's gonna lead to the heart failure. So this is the first type of the cellular adaptation, which is hypertrophy. Now let's talk about the hyperplasia, and The hyperplasia is simply you're increasing the number of the cells, and the number of cells leads to the increased number of the organ enlargement, and of course, if this type of cellular adaptation will happen in the cells which are able to divide, like the breast cells, like the liver cells, or yeah, like the endometrial cells. These cells are a great example of which can divide, right? So it results from the hormonal stimulation or from the increased functional demand. That is very understood, that if you're gonna give a lot of growth factors, a lot of growth hormones to a cells that are capable to divide, then of course it will lead to the hyperplasia. And a best example of that would be your somatic cells. If you're providing a lot of growth hormones, then of course it will lead to a lot of cells that are division, and your somatic cell will divide and your body size will increase, right? So this is another example of the hyperplasia. Another example of it would be if increased functional demand. If you're providing a lot of functional, if you're providing a lot of stress again to the cells that are capable to divide, then this would also lead to the your hyperplasia, right? So a big detail would be that the stress leads to the increased growth factor, and these growth factor leads to increased number of mitosis, and this mitosis again occurs if the number of cellular division in the form of mitosis is being increased, then this leads to the increased number of cells. All right. Now this hyperplasia can be physiological or it can be pathological. The physiological hyperplasia example would be the breast glandular proliferation in response to the puberty or pregnancy. Or when you reach the state of puberty or when you reach the state of pregnancy, you are in a hyperestrogenic state, and this high number of or large number of estrogen in your blood leads to the increased number of the increased division of the cells of your breast, and this is called as breast glandular proliferation, and that's an example of the hyperplasia. Similarly goes for liver regeneration. Liver is an organ of your body which has a capability to regenerate. So if there is if you simply, let's suppose that you cut off the lobe of a liver, and now this would lead to the increased number of growth hormone signaling pathway or some growth factor signaling pathway. This would be the correct term, and these growth factor signaling pathway would lead to the increased number of cells in the liver, and this is how, just because of hormonal stimulation, you are increasing the number of cells, and this is called hyperplasia. Right now, again, this is very controlled, this is very reversible. If it is not controlled and if it is not reversible, then this is simply the neoplasia. Right, it is simply the neoplasia, and you are entering into the into the ground of the your neoplasia, right? So that's a different topic. Now, again, if the hyperplasia is pathological and if it's persistent, it's occurring back to back, you're providing a lot of stimulus, then easily it might lead to the dysplasia and malignancy. Dysplasia and malignancy is a different topic, and this would be the next topic, and I will of course upload a video on that. So yeah, this is how it is gonna occur. Alright, now let's talk about the atrophy. Now, atrophy is the next type of cellular adaptation, and atrophy is simply the decrease in the cell size or cell number, because it simply happens that when you are not providing the enough stress, when there is no demand of a cell or a tissue, then of course the size or the number of that tissue or that cell gonna decrease, and this is simply called as atrophy. There is no big science or rocket science in that. Just understand it's like, because you are not providing the stress, you're not providing the demand. There is no demand. If there is no demand, then there is no growth factor signaling pathway, and if there is no growth factor signaling pathway, then there is no division of the cell, and this will lead to the atrophy. That's simple. You can also understand this in a simple way, another way, that for suppose if there's a product in the market and there is no demand of that product, of course the company is not going to make that product, and ultimately that product will disappear from the market, and that's how simple atrophy is. Okay, so atrophy occurs to you again if you're not, for suppose, let's suppose there is a patient who got a stroke, and that patient is not using the is not using that limb in which is affected as a result of a stroke. So of course there is decreased workload to that limb, and that limb is gonna atrophy ultimately. That's why the patient who got a stroke, they are admitted to the rehab center, rehabilitation center, physiotherapy center as soon as possible once after the acute stroke is managed. So that's what a basic thing is. But keep in mind that the mechanism that is involved in the atrophy is the reduced protein synthesis, because again gene expression is not there. There is no growth factor signaling pathway. If there is no growth factor signaling pathway, there is no gene replication, there is no gene expression, and this would lead to the reduced protein synthesis. All right. And another thing is that increased protein degradation. uh, there is something called as ubiquitin proteasome pathway, and that pathway, the ubiquitin proteasome pathway, is a pathway that simply digest the protein within your cells, and this pathway is also a major mechanism of the atrophy. Just consider that ubiquitin proteasome pathway is sort of a machinery that digest, that engulf, that degrade the protein in your cells. And of course the core principle, the outline of the atrophy is to decrease the number of protein in your cell. So it can be via due to reduced protein synthesis, or it can be via ubiquitin proteasome pathway, which digests the protein by by engulfing or by some different mechanism that is simply degrade the protein. All right. So that's it. Now the atrophy can be physiological, as in like uterine involution. If, for suppose, once a child is delivered, after the delivery, so now the uterus has to involute, right? Because the uterus, there is no need to be, there is no need for the uterus to be much enlarged now. So uterus has to go back to its normal size. So for that, the cells which were present as a response of hypertrophy, those or hyperplasia, those cells must die now. So the mechanism for that is atrophy. All right. And thymic atrophy with age, because of course when you are aged enough, there is no need of thymus, so thymus will stop functioning, and if the gland is not functioning properly, there is no use of the gland, and this will lead to the atrophy. So it's a very natureful mechanism. If you're not using something, it's gonna atrophy. That's it. I explained the pathological type of atrophy as an example of the stroke patient already. Okay. So severe or prolonged atrophy may impair function. Yeah, that's a very simple concept. That if you're not if the cell if you're not using a muscle or some cell for a longer time, and then it will, of course it will lead to the atrophy, and if the atrophy is prolonged, then it will lead to the impaired function of the cell, and this leads to the cellular injury or cell death. Now the last topic for this is metaplasia, and metaplasia is, as I explained earlier, Jan, that metaplasia is a type of cellular adaptation in which one type of epithelium or one type of cell is replaced with the another type of cell. All right, so it's a very programmed thing. It's a very you can say it's a very organized thing that nature provide us. So, for suppose if you are, it's a very good example of this is the buried esophagus due to the chronic acid reflux. For suppose I won't go into the detail of the type of the epithelium here, because many people by this time don't remember the type of epithelium, so I will just keep it simple. For suppose there is a type of epithelium in the esophagus, and that epithelium is called epithelium A, right? And that epithelium A is very good. All right, if you're just passing the food by the esophagus, that epithelium is good to go. It's 10-10, right? Now, as a response, or for suppose you're having the acid reflux, right? If you are having the acid reflux in your body and in your stomach, then this acid would be refluxed to your, that there is a stomach, and the stomach, the esophageal sphincter prevents the reflux of the acid in the stomach back into your esophagus, right? Now, for suppose due to some reason that esophageal sphincter is not functioning well, so of course the acid in the stomach will be refluxed back into your esophagus, all right? And now your esophagus is not good enough to deal with the type of epithelium of the esophagus is not good enough to deal with this acid. So ultimately your body will reprogram the stem cells of your esophagus will reprogram, and this will lead to a new type of epithelium production, and a new type of epithelium will be present there, will be formed, and this type of epithelium, which is epithelium B, is good enough to protect your esophagus from this acid. Alright, so this is called as metaplasia. You're simply converting one type of epithelium into another type of epithelium, one type of cell into another type of cell, and keep in mind that this is a very programmed pathway which involves the reprogramming of the stem cells. Alright, so that's it for, again, keep in mind that if uh, okay, so yeah, it is very common that if you're providing a new type of epithelium, like if you're converting the body from the epithelium A to epithelium B, then there might be loss of some specialized function, because epithelium B is not good enough for those functions which the epithelium A was performing. So yeah, there might be loss of some viable functions, but again, it's a very good response to the stress, because at least you are saved from the stress, you survive the stress. Once the stress is gone, you're gonna replace back your epithelium, and the function will be same. All right, so if there is persistent stress, so this metaplasia will might lead to the conversion into the dysplasia, and once you enter into the line of dysplasia, you are at a huge risk of the malignancy. All right, so that's why metaplasia is very clinically significant, because once there is buried esophagus, we treat it. We don't leave buried esophagus. We treat it as soon as possible, because we don't want this buried esophagus to be converted into the carcinoma of the esophagus. Alright, so that's it from my side. If you have any questions, any queries, you can contact us on our Instagram page. And keep in mind that we also provide the one-to-one mentorship and tuition to many USMLE Step 1 Step 2 CK candidates. We had good reviews. Many people come, and we receive many thanks message and many pass and a good score transcripts, and alhamdulillah, we're doing a very good work. If you have any queries and if you want to contact us, and contact us on our Instagram page, like, comment, share, subscribe. Thank you.